Next, we discuss about the LDR disadvantages. First one, poor temperature stability. It means, even the best LDR materials are sensitive to temperature changes, which can affect accuracy. Second one, slow response time. It means, more stable materials respond slowly to changes in light intensity. Third one, limited use in fast-changing light conditions. It means, LDRs are not suitable for applications where light levels change rapidly. Next we discuss about a brief explanation of each application of LDRs, light-dependent resistors. First one, automatic street lighting. It means, LDRs detect the ambient light level and automatically turn street lights on at dusk and off at dawn, saving energy. Second one, light intensity meters. It means, used to measure the brightness of light in various environments, useful in photography, agriculture, and lab setups. Third one, solar garden lights. It means, LDRs help solar lights detect nightfall so they can automatically turn on without manual intervention. Fourth one, security systems. It means, employed to detect changes in light levels caused by movement or obstruction, triggering alarms or cameras. Fifth one, camera light meters. It means, built into cameras to measure available light and help adjust exposure settings for better photo quality. Sixth one, brightness control in displays. It means, automatically adjusts screen brightness on devices like phones or TVs based on surrounding light conditions. Seventh one, industrial automation. It means, used in manufacturing for detecting light-related conditions, such as product presence or alignment on conveyors. 8.1. Robotics. It means, LDRs assist robots in detecting light sources, enabling behaviors like line following or navigation toward, away from light. Next, we discuss about the surface mount resistors. Surface mount resistors, SMD resistors, are tiny electronic components used to restrict current flow in circuits. Unlike traditional through-hole resistors that have leads that penetrate a circuit board, SMDs are soldered directly onto the surface of the board. They are commonly used in electronic equipment due to their small size, high reliability, and ability to be placed on both sides of a circuit board, which allows for a higher density of components. Surface mount resistors, SMD resistors, are generally rectangular in shape. They are also known as chip resistors. These small, rectangular components are designed for surface mount technology, SMT. They are typically made from ceramic or metal oxide materials and offer advantages like small size, high reliability, and suitability for automated assembly. A surface mount device, SMD, is an electronic component designed to be mounted directly onto the surface of a printed circuit board, PCB, using a process called surface mount technology, SMT. SMT is the method of attaching SMDs to the PCB. In simpler terms, SMDs are the components like resistors, capacitors, and integrated circuits that are used in SMT to build electronic devices. Next, we discuss about the construction of the surface mount resistors. Surface mount resistors, also known as chip resistors or SMDs, are constructed by depositing a resistive film, usually metal oxide or metal film, onto a ceramic substrate. While the statement about a thick carbon film is partially accurate, the more common construction involves other materials like metal oxides or metal films. The resistive film is then carefully trimmed to achieve the desired resistance value. The resistance value of a surface mount resistor is indeed determined by the carbon composition and the amount of trimming done. The composition of the carbon, including the ratio of carbon to binder material, significantly impacts the resistance. Trimming, often using a laser, allows for fine-tuning of the resistance by removing material and thus increasing it. These resistors are designed for surface mounting on printed circuit boards and often use thin film or thick film technology where trimming is a common process. Surface mount resistors can have resistance values ranging from a fraction of an ohm to several million ohms, megaohms, depending on their application and design requirements. Surface mount resistors, SMD resistors, typically have power dissipation ratings ranging from 1/8 watt to 1/4 watt. These ratings are crucial for ensuring the resistor doesn't overheat and potentially fail under normal operating conditions. A resistor's power dissipation rating refers to the maximum amount of electrical power it can safely convert into heat without overheating. A 1/8 watt rating for a resistor, like a resistor, means that it can safely dissipate 0.125 watts of power as heat. This power rating indicates the amount of electrical energy a resistor can convert into heat without overheating. If the resistor is subjected to a higher power level, it could overheat and potentially fail. A 1/4 watt designation, typically on a resistor, means the component can safely dissipate a maximum of 0.25 watts of electrical power. This power rating indicates the amount of heat the resistor can handle before overheating or failing. Surface mount resistors, SMD resistors, utilize two leadless solder end electrodes for electrical connection to the resistive element. These electrodes are typically located on opposite ends of the rectangular ceramic body and are made of conductive materials like silver. This design allows for easy soldering to a printed circuit board (PCB). When surface mount resistors have C-shaped end electrodes, it means the metal electrodes wrap around the end and part of the bottom of the resistor body in a C profile. Next, a surface mount chip resistor with dimensions approximately length 0.125 inches means 3.2 millimeters. Width 0.063 inches means 1.6 millimeters. Thickness 0.028 inches means 0.7 millimeters. This size corresponds to the 1206 package code in the surface mount device sizing system. 1206 means 0.12 inch into 0.06 inch in imperial units. 3.2 millimeters into 1.6 millimeters in metric units. This is a common size for 1/8 watt means 0.125 watt surface mount resistors. Surface mount resistors are significantly smaller than conventional resistors with axial leads. Surface mount devices are typically square or rectangular with low profiles, and their terminations are soldered directly to the surface of the printed circuit board, unlike through-hole resistors that have wire leads that pass through the board. Chip resistors, also known as surface mount devices, are known for their temperature stability and robustness. They are built using metal glaze or thin film technology, which allows them to maintain accurate resistance values even under temperature fluctuations. Their rugged construction, often including protective coatings, makes them suitable for various harsh environments. The end electrodes are soldered directly to the copper traces of a circuit board, hence the name surface mount. Simply, the statement accurately describes surface mount technology. Surface mount technology involves mounting electronic components directly onto the surface of a printed circuit board using solder. These components, known as surface mount devices, have electrodes that are soldered directly to the copper traces, also called pads, on the PCB's surface. This method is called surface mount because the components are mounted on the surface of the PCB, not through holes as in through-hole technology. The image shown is a 0805 SMD resistor, a type of surface mount device commonly used in electronics. It is a small, rectangular component designed to be mounted directly onto the surface of a printed circuit board. The surface mount resistor components. First one. Ceramic body. It provides the main structure. Second one. Resistive element. It determines the resistance value. Third one. Component contacts. It metallized areas at each end for soldering to the PCB. Fourth one. Insulating protective coating. It protects the element. 0805 indicates dimensions of 0.08 inches means 2 mm in length, and 0.05 inches means 1.25 mm in width. Next, surface mount resistors offer several advantages over their through-hole counterparts, including smaller size and weight, higher component density, better high-frequency performance, cost-effectiveness for mass production, and improved thermal performance. First one. Smaller size and weight. It means surface mount resistors are significantly smaller and lighter than their through-hole counterparts, allowing for smaller and lighter electronic devices. Second one. Higher component density. It means surface mount technology allows for greater component density on printed circuit boards, enabling more components to be packed into a smaller area. Third one. Better high-frequency performance. It means the shorter signal paths and reduced parasitic inductance and capacitance of surface mount technology components contribute to improved high-frequency performance. Fourth one. Cost-effective for mass production. It means surface mount technology is well suited for automated assembly, reducing production time and labor costs, making it cost-effective for mass production. Fifth one. Improved thermal performance. It means surface mount technology components can dissipate heat more efficiently due to their smaller size and better thermal management capabilities. Next, we discuss surface mount resistors present some disadvantages. They can be difficult to handle manually due to their small size, limiting their use in prototyping and breadboarding. Additionally, Their small size restricts power handling capacity, and they are susceptible to damage from mechanical stress, especially when subjected to thermal cycling or vibration. First one. Difficult to handle manually. It means the small size of surface mount devices makes them challenging to manipulate, solder, and repair by hand, especially for complex designs or for less experienced individuals. Second one. Limited power handling. It means surface mount DW devices are generally designed for low power applications, and their power handling capacity is lower than their through-hole counterparts. Third one. No prototyping breadboard compatibility. It means surface mount devices are not readily compatible with standard breadboards or prototyping boards, which typically accommodate through-hole components. This limits their use in early design stages or for experimentation. Fourth one. Mechanical stress sensitivity. It means the solder connections for surface mount devices are more prone to damage from mechanical stress, thermal cycling, or vibration, especially if not properly supported or if the printed circuit board is subjected to repeated flexing. Next, we discuss about applications of the surface mount resistors. Surface mount resistors are widely used in various electronic devices due to their compact size and ease of assembly via surface mount technology. They find application in consumer electronics, automotive electronics, medical devices, telecommunication equipment, and industrial controls. First one. Consumer electronics. It means surface mount resistors are essential in devices like smartphones, laptops, and other compact gadgets, where space is at a premium. Second one. Automotive electronics. It means these resistors are used in automotive applications, including sensors and engine control units, due to their reliability and ability to withstand harsh conditions. Third one. Medical devices. It means surface mount resistors enable the miniaturization of medical equipment, enhancing portability and functionality. Fourth one. Telecommunication equipment. It means they are used in telecommunications infrastructure and devices. Fifth one. Industrial controls. It means surface mount resistors are utilized in various industrial control systems for their reliability and performance. Next, we discuss about the applications of the resistors. Resistors have numerous applications in electronic circuits and devices. They are primarily used to control the flow of current, regulate voltage levels, protect sensitive components, and generate heat. First one. Current limiting. It means resistors are used as current limiting devices to control the flow of current in circuits, particularly to protect components like LEDs from damage due to excessive current. By introducing resistance, resistors prevent too much current from flowing through a component, ensuring it operates within safe limits. Second one. Voltage division. It means voltage divider circuits utilize resistors in series to create multiple voltage levels from a single source. By adjusting the ratio of resistors, the circuit divides the input voltage into different output voltages, effectively scaling down the input voltage. This is a fundamental concept in electronics used for various applications like reference voltage generation and signal attenuation. Third one, heat generation. It means resistors are fundamental components in various heating appliances. Their ability to generate heat when current flows through them makes them ideal for applications like electric heaters, toasters, and electric stoves. Fourth one, biasing of transistors. It means resistors play a crucial role in biasing transistors by establishing a stable DC operating point that allows the transistor to amplify an AC signal correctly. This involves setting appropriate DC voltages and currents within the transistor circuit to ensure reliable and stable operation. Fifth one, signal conditioning. It means resistors play a crucial role in signal conditioning by facilitating the conversion of a physical quantity, like force or temperature, into a measurable electrical signal. They are used in various applications, including Wheatstone bridges, potentiometers, and amplification circuits, to manipulate and prepare signals for further processing. Sixth one, pull-up and pull-down resistors. It means pull-up and pull-down resistors are used in digital circuits to establish a default high or low logic state for input pins when there's no external signal. They ensure a defined voltage level, preventing inputs from floating and causing unpredictable behavior. Seventh one, timing circuits. It means resistors in timing circuits, particularly in combination with capacitors, means RC circuits are crucial for controlling the rate at which a capacitor charges and discharges. This rate, which determines the timing, is directly related to the resistance and capacitance values, affecting applications like generating pulses, creating delays, and making oscillators. Eighth one, feedback in amplifiers. It means in amplifiers, resistors are crucial for feedback, which significantly impacts the circuit's performance. They control gain, stability, and frequency response. Feedback, whether negative or positive, uses a portion of the amplifier's output signal to modify the input, influencing the overall gain and stability. Next, we discuss about the color coding of a resistors. An electronic color code is a standardized system of color-coded bands used on electronic components to indicate their values and ratings, such as the resistance of a resistor. This method is particularly useful for small components where printing numerical values would be difficult or impractical. An electronic color code is a code that is used to specify the ratings of certain electrical components, such as the resistance in ohms of a resistor. The primary purpose of the color code is to quickly and easily identify the resistance in ohms of a resistor, as well as its tolerance, the allowed deviation from the stated resistance value. Next, working of color of resistors. The resistor color code, often used to identify resistance values, employs color bands to denote the significant figures, multiplier, and tolerance. The first two bands typically represent the significant figures of the resistance value. The third band indicates the multiplier, example how many zeros to add, and the fourth band specifies the tolerance, the allowed variation in the resistance value. Next, we discuss about the significant figure component. Significant figures means first two bands. Each color corresponds to a specific number, 0 to 9. Numbers represent the first and second digits of the resistance value. For this example, refer to the figure above with a green, red, blue, and gold band. Using the table provided below, the green band represents the number 5 and the red band is 2. Next, we discuss about the multiplier. Multiplier means third band. The multiplier indicates the power of 10 by which the significant figures are multiplied. For example, a multiplier of 100 means red band would mean the resistance value is the significant figures multiplied by 100. The third, blue band, is the multiplier. Using the table, the multiplier is thus 1 million. This multiplier is multiplied by the significant figures determined from the previous bands, in this case 52, resulting in a value of 52 million ohms, or 52 megaohms. Next, we discuss about tolerance. In resistor color coding, the fourth band, when present, indicates the tolerance of the resistor. If the fourth band is missing, the tolerance is typically assumed to be 20%. 4-band resistors. The first two bands represent the first two digits of the resistance value, the third band represents the multiplier, and the fourth band indicates the tolerance. Resistor tolerance represents the permissible variation in the resistor's resistance value, expressed as a percentage. It indicates the maximum deviation from the nominal resistance value that the resistor is guaranteed to maintain. For example, a resistor with a 5% tolerance means its actual resistance can vary up to plus or minus 5% of its stated value. A gold band in a resistor's color code indicates a tolerance of plus or minus 5%. This plus or minus 5% tolerance is often represented by the letter J. For example, a resistor with a value of 52 megaohms and a gold band would have a range of acceptable values between 49.4 megaohms and 54.6 megaohms. Already we explain, the image shows a resistor, an electronic component that limits the flow of electric current in a circuit. The colored bands on the resistor indicate its resistance value. Resistors control current flow and can reduce voltage in a circuit. Resistance is measured in ohms. Resistors can be fixed or variable. Color code. The bands represent numerical values, multipliers, and tolerance. Resistors are used to limit current, divide voltages, and bias active elements in circuits. Next, we discuss about the color coding table. First column indicates color. Second column indicates first and second band significant figures. Third column indicates multiplier. And fourth column indicates tolerance. On the resistor, the black color band. First and second significant figures 0. Multiplier 1. On the resistor, the brown color band. First and second significant figures 1. Multiplier 10 and tolerance value plus or minus 1% F. On the resistor, the red color band. First and second significant figures 2. Multiplier 100 and tolerance value, plus or minus 2% G. On the resistor, the orange color band. First and second significant figures 3. Multiplier 1000 and tolerance value. Plus or minus 0.05% W. On the resistor, the yellow color band. First and second significant figures 4. Multiplier 10,000 and tolerance value. Plus or minus 0.02% P. On the resistor, the green color band. First and second significant figures 5. Multiplier 100,000 and tolerance value. Plus or minus 0.5% D. On the resistor, the blue color band. First and second significant figures 6. Multiplier 1 million and tolerance value. Plus or minus 0.25% C. On the resistor, the violet color band. First and second significant figures 7. Multiplier 10 million and tolerance value. Plus or minus 0.1% B. On the resistor, the gray color band. First and second significant figures 8. Multiplier 100 million and tolerance value plus or minus 0.05% L. On the resistor, the white color band. First and second significant figures 9. Multiplier 1 billion. On the resistor, the gold color band. Multiplier 0.1 and tolerance value. Plus or minus 5% J. On the resistor, the silver color band. Multiplier 0.01 and tolerance value. Plus or minus 10% K. Where F, G, W, P, D, C, B, L, J, and K indicating a specific IT grades means international tolerance grades. This system ensures interchangeable parts can be within defined limits. Where the plus or minus sign indicates a bilateral tolerance, meaning the variation is permitted in both positive and negative directions from the nominal dimension. Padmam Hemam. Thank you very much.